When you look up at the night sky, it seems like we understand a lot about the universe. We see stars, galaxies, planets. But did you know that everything we see makes up only about 15% of all the matter in the universe? The rest is something we can't see, an invisible, mysterious substance known as dark matter. And what if I told you that tiny microscopic black holes might hold the key to unlocking this cosmic mystery? For every kilogram of matter that you can see, from your phone to distant stars, there are about 5 kilograms of dark matter hiding in the shadows. Dark matter doesn't emit light or energy, making it impossible to observe directly. Yet, its gravitational pull influences the movement of stars and galaxies, suggesting it must be there. Enter Stephen Hawking. In 1974, the legendary physicist proposed a bold idea. What if dark matter is actually made up of black holes? Not the massive black holes formed by collapsing stars, but microscopic primordial black holes that formed in the first moments after the Big Bang. These tiny black holes, he theorized, could be scattered throughout the universe, explaining the elusive dark matter we've been searching for. Primordial black holes would have formed in the first quintillionth of a second after the Big Bang. Unlike the colossal black holes we think of today, these would have been minuscule, but incredibly dense, perhaps packing the mass of an asteroid into the size of an atom. Imagine the incredible gravitational pull these tiny, invisible objects would have. Fast forward to today, and a team from the Massachusetts Institute of Technology, MIT, has taken Hawking's idea even further. Professor David Kaiser and his graduate student Elba Alonso Monsalve have uncovered evidence that suggests these primordial black holes could possess an unexpected characteristic, something called color charge. In the realm of particle physics, color charge refers to a property carried by quarks, the fundamental particles that make up protons and neutrons. Soon after the Big Bang, the universe was an extremely hot soup of quarks and gluons. As the universe cooled, these particles combined to form the nuclei of atoms. But during that initial hot phase, any black holes forming could have captured these quarks and gluons along with their color charge. Kaiser and Alonso Monsalve realized that black holes forming in this environment could end up supercharged, containing the maximum color charge allowed by the laws of physics. These supercharged black holes, unlike anything we've ever seen, would have been an entirely new state of matter, though they would have evaporated almost instantly after their formation. But even if they existed for just fractions of a second, these supercharged microscopic black holes could have left behind unique imprints on the universe. They could have influenced how the first atomic nuclei formed, a crucial moment in cosmic history occurring just 1 second after the Big Bang. By disturbing the equilibrium conditions during this critical phase, these black holes might have left behind subtle signals detectable by astronomers today. So, what are these signals we might be able to detect? They could be tiny deviations in the abundance of certain elements, or even shifts in the cosmic microwave background, the faint afterglow of the Big Bang that permeates the universe. By studying these signals, we can learn a lot about the early universe's physics and potentially even confirm whether primordial black holes could account for all dark matter. This is an exciting frontier in cosmology. Traditionally, scientists have explored a range of dark matter candidates, like weakly interacting massive particles, WIMPs, or axions. But the idea that dark matter might be composed of microscopic black holes offers a new perspective, a way to connect quantum physics with the large-scale structure of the universe. Dark matter is crucial for explaining how galaxies form and evolve. Without it, the stars and gas in galaxies would have spread out far more than they have. But if primordial black holes, formed in the chaotic aftermath of the Big Bang, are the answer, then our entire understanding of the universe's structure could shift. Imagine the implications. If all dark matter in the universe is made up of these microscopic black holes, it would not only solve one of the biggest mysteries in modern science, but also open up new questions about the very fabric of reality. Researchers around the world are racing to test this theory, using powerful telescopes and new experiments designed to look for the unique signals left behind by these tiny, ancient black holes. The quest to understand dark matter isn't just about solving a cosmic puzzle. It's about understanding the universe at its most fundamental level. The cosmos is full of mysteries waiting to be uncovered. As we learn more about the universe, we uncover new layers of complexity and beauty hidden within the fabric of reality. Stay tuned for more deep dives into the wonders of space, and don't forget to subscribe, like, and share to join us on this journey through the stars.